Okay, I'm going to talk today about monitoring-driven debugging. Let's start firstly what is in general debugging and what are commonly used debugging techniques. According to Wiki, debugging is a process of finding and resolving defects of problems of computer program or some system. And commonly used debugging techniques are print debugging, which is like just adding logs and looking where exactly it stopped working, remote debugging, SSH to server, reading logs, and so on, postmortem debugging, Wolf-Fence algorithm, and a bit more, but the idea here is that all of the debugging techniques right now, they are about tests. You have to reproduce an issue, then you have to reproduce it a few more times with some different conditions which are proving or not proving your ideas of what can go wrong, but you need to do tests. Does it work every time? Actually, no, because in a large-scale problems, in a large-scale systems, there is a problem with debugging it. Debugging using tests is problematic to scale for large-scale and complex system. Let's look at the example. We had a problem at Wix when just 7% of all our RPC calls started failing with some RPC transport exception, which tells basically nothing. It occurred in all our microservices. We have more than 1,000 of them, and it happened on all application servers. We also have more than 1,000 of them. First thing what we tried to do, we wrote a test to reproduce an issue, just some small script which sends RPC requests to microservices and log all the failures. Pretty straightforward. We ran it for a few hours and got nothing. 0 exceptions, nothing. Meaning that basically in order to reproduce an issue and in order to start debugging, we need to check all the possible cases of all the possible calls, and then probably some of them will fail. Let's try to calculate how many tests we need to do. 100 microservices, each makes at least 2 requests and gets 2 requests, so 4,000 calls. 1,000 servers multiplying 4,000 calls, it's already 4 million calls. And 7% failure rate basically says that every 15 requests is failing. So in order to have close to 100% probability of find a failed request, we need to do at least 15. So 4 million calls multiplying 15, it's 60 million requests. Basically 60 million tests we need to do in order to debug the issue. That's definitely not going to take 5 minutes, and it was an incident in production, which means we need to fix it as soon as possible. So we needed to change our debugging approach, and that's how we got to monitoring-driven debugging. The idea is of this approach that it allows to debug issues without need to reproduce it. Basically, you're looking at monitoring and you start any incident with just opening graphs and looking what went wrong and what happens on your graphs and not from reproducing the issue. In the previous case, what we discussed, the issue was in the end that someone changed rights on resolve.conf file on one specific application server. And user which runs microservices just couldn't read this file, which means no DNS resolution for microservices on that server, which means no RPC request, of course. Using tests, we found the issue in 2.5 days, 60 million, remember. After we added monitoring on DNS resolving from applications, next time the issue happened, we found it in 2 minutes, and in 3 more minutes we fixed it. That's it, no 2.5 days. A bit of pros and cons. Pros, it's fast and precise. It doesn't require any tests. It allows to add alerts. It also allows you to add auto-remediation if you have correct alerts and if you know exactly what you need to do based on which alert. And it's also good for big and complex system. Some of the cons, it's price of monitoring. If you're collecting a lot of metrics, it's a lot of data, you need to pay for it, it's costs. Too much of monitoring data can be confusing. And also it's pretty long curve to set up monitoring to be useful in debugging, because you need to know, you don't need to have too much data, you don't need to have too small amount of data, and it should be calibrated. More than that, reproducing issues in test cases requires a solid hypothesis on what's the cause of the issue. You need to have any ideas what can go wrong, and then you're testing to prove idea or to check that it's wrong. Monitoring only need to capture a symptom, so it's basically glowing from the different side. And using monitoring-driven debugging, basically 6 stages of debugging becomes just 3 from that can't happen to oh, I see. Thanks.